Good evening, ladies and gentlemen, and welcome to all of you. My name is Terry Bilson, and I'm the CEO of a company called Axiom Global Holdings. Axiom is a shareholder and investor into rubber nano products, the company we'll be talking about tonight, and more specifically the technology Activate, which is the third generation of the technology that's been in the development for over 10 years now. The technology was born out of the doctoral research done by Mr. Robert Bosch here at Nelson Mandela Bay University. What Activate has brought is the ability to make better rubber more cost effectively, more efficiently, and increasing throughput. Now, I can't imagine one CEO or CFO or production director that wouldn't want to achieve what I've just said. I know it sounds too good to be true, so what I'd like to do is let Robert just give you a brief outline of how the technology works and a bit more about the chemistry, and then I'll share some more information about a South African customer who adopted the technology early this year, and through adopting the technology was able to increase his throughput significantly. I think it was threefold, reduce the temperature on the press, and became hence more competitive and won a big international export order. So I'll let Robert introduce you a bit more about the chemistry. Thank you very much.
Rubber Nano Products is a chemical technology company specializing in the vulcanization of rubber. The company has generated over 5 patents in the last 12 years and has gone through 3 major generations of our technologies. The manufacture of rubber articles uses a chemical process called vulcanization. Vulcanization is when certain chemicals are combined together inside the molten rubber at high temperature and pressure. These reactions require certain ingredients to come together in a chemical synthesis, which then forms the rubber system that we desire, like a tire or a belt. The use of this technology, or vulcanization, requires one to have certain solid components as well as liquid components working together. These interactions are, of course, now surface area limited. Now, what the company has done throughout its 3 generations is it began to utilize novel nanoparticles that improved these interactions and the rate thereof. It then developed coated nanoparticles to improve these interactions, until finally, in the 3rd generation, the company decided to start using novel ionic liquid systems, which allow us to even dissolve some of the other solid components inside the system. Now, what effect does this have? In the context of rubber curing, it is important to understand the cure rate. This is the acceleration of the cure system. Initially, we were achieving around a 10% improvement in the maximum rate, and this of course had realistic results. We improved that with our 2nd generation technology to around 20%. The use and advent of ionic liquid systems and technology has now allowed us to improve that maximum cure rate to at least 250% from the previous generations. This is significant. Now, what is Activate and what is our technology? Our technology we are calling Activate, and it is based upon a novel ionic liquid system designed for rubber itself. This material then dissolves inside the rubber during simple mixing and allows us to dissolve and improve the interactions of all the components, the sulfur, the accelerators, the zinc that is left in the system, and achieve certain workable results that are better than what is currently around. Of course, what is an ionic liquid? Well, an ionic liquid is essentially a salt that is a liquid below 100 degrees. Now, it is a very good solvent. It dissolves zinc oxide, it can dissolve the sulfur in the system, and it can dissolve all sorts of organic accelerators. Now, what does this achieve? Well, first of all, our Activate technology and the first initial prototypes of the technology allowed us to improve the cure rate of all the diamine rubbers, all the industrially relevant rubber systems. It worked independently of what accelerator was used, and it allowed us to work independently of the zinc type. Essentially, we are not surface area limited by certain components anymore, unlike all the previous vulcanization technologies. Our modulus is greatly improved in the rubber systems, proving a better interaction between the rubber and filler systems, and our cure rates are essentially greatly improved. Now, what did this else achieve? It allowed us to start rationalizing certain components and zinc levels inside the rubber systems. It also allowed us to improve the physical and especially the dynamic properties of the rubber, very critical for conveyor belting and tires. It also turned out that our technologies was improving certain other ancillary reactions like blowing reactions, activation, and kicking. So in conclusion, our technologies and the product Activate or Premix Activate, the REACH-approved version, will enhance curing in all known sulfur-based dyeing system, will allow rationalization of certain ultra-accelerators and of course the removal of DPG, a material under the scrutiny right now for workplace safety. It will interact with the rubber and the filler to improve the dynamics of the system. It will improve the efficiency of manufacture, the time required to cure the part and the energy required to actually cure parts, and will also allow environmentally appropriate zinc reductions. Thank you.